Yeah.
Yeah, what's the plan for the winter break?
I'm not sure. You got anything going on?
You're not taking classes, right?
Not during winter break.
Not during winter break. Yeah. Well, people. Hi, Tim.
Hi.
Hi, Donovan.
How's it going?
All right. So we have 2 lectures left total. And then Monday will be our final exam. And good luck to that. So today we're going to talk about something called REST protocol, REST, R-E-S-T. And then we're going to talk about HTTP protocol. Very interesting topic. We're not going to do anything, but I just want to introduce you to the concepts. It's very, 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 very important. Okay, so as usual, I will start with something you already know. Okay. We are familiar with the programs we write, right, for the last 2 years, if not more. Essentially, the programs we write are typically called client. Okay, so client program. For example, when you write your Java code, it's really something show up on your computer. It's for humans to use, right? Sounds crazy, trivial, but our programs don't contact another computer somewhere else to get the data, nor do our computers will send the data to other computers somewhere else, right? So we often call this kind of programs desktop applications, the ones we've been writing. They're called desktop applications. They're meant for humans to use. So that's why we often use GUI, graphic user interface. The keyword is in interface, right? That's interface means something is interacting. In this case, is humans, the users, and the program. Okay, so if you think about it, the graphic user interface is really something allow users to interact with our program, right? So we can type some data into a text field, we can click on a button, so on and so forth. Okay, so these are called desktop applications. All right, so something similar to this could be done for our mobile devices. Okay, even though not for desktop, mobile devices. And in this case, we often call them apps, APP, apps. Okay. And in that event, they still, even if you put your program onto which you could put it onto your mobile phones, they are called apps, but nevertheless, the programs we wrote so far do not contact another computer somewhere else and try to get data from there or send data over there. So there's no connection between our computer and another computer or any other computer anywhere else, right? So it's all like a standalone. It's called a standalone, right? So that is really what we've been doing, okay, even though we spend so much time on it. But in the real world, things are not more complicated than this. For example, we often have a program that will need to contact another computer somewhere else to retrieve data. A good example is like we use a web browser, okay, that you enter some URL and then the browser will contact another computer somewhere else, say Google or email server, to get information, right? So in that case, it's called client and server configuration or client server applications. Okay, so that's a very different kind of application. Okay, that basically involves communications between computers, not just one computer. Now, right, you think about it, all the programs we wrote is really running on our computer or on someone else's computer separately from the internet. Okay, you can just run it, everybody can run it on the computer as an individual application, but there's really no communication between our computer and another computer. Okay, last week when we're talking about databases, we are almost there. We are almost there. But we didn't venture out to that stage. What we did was there was an opportunity, which was we need a database. I mentioned that most databases are running on a separate computer as a server. So it's kind of a server client relationship. For example, it's often to have a database server somewhere else on the internet. Okay, say the Oracle server could be somewhere else. Microsoft SQL server could be somewhere else. In fact, any kind of server, database server could be somewhere else. Okay, so in that case, the file, remember that the SQLite file? Okay, that will be somewhere else, not on our computer. But we didn't do that. Instead, we chose to store the SQLite file in our project folder on our own computer, correct? So we didn't really venture out to the network, the internet, to use the service from another computer. So because of that, essentially up to this point, we are still a desktop application, right? There's no server used at all. Okay, so far. Although we are close, we could have installed MySQL or Oracle server, or Microsoft server on another computer. Okay, in fact, Google or Amazon or Oracle, they all provide such database servers on the cloud. Everybody can use, but we didn't use it because that was kind of too complicated for this class. We don't have enough. In other words, all those big companies they have already set up their database servers on the internet. Okay, either you have to pay a little bit of money to use the server, or you can use it for free if it's small scale or for nonprofit. Okay, so in fact, it's very common. So in that case, then we are in a new system called client server, because then our computer, our application will be a client. Okay, and the server that provides database service, that will be the server on the cloud. Okay, you understand the difference, right? So we didn't really venture out, but it's there. Okay, it's there. It's widely used, called cloud service, and the most player in this field is called Amazon. Amazon, what they call it? Amazon
Web services.
Amazon Web Services, AWS. Yes. So that's the biggest player, has probably about 50-60% of the market share, growing exponentially. And also the second biggest player, I think, is Google. So Google Cloud. So they are gaining market share. So there is a piece out there we never really used. Okay, so we're going to talk about it today, and then we're going to talk about a bigger picture, how things are putting together. Okay, what are the structures, or what are the components? Okay, now you often hear people say apps. I'm sure you've heard of that, because we put our apps on the phone, right? And then with the apps like WhatsApp, you heard about WhatsApp, or you may have used it. It's such an example. You download, put on your phone, right? And then if you send a message to someone, and that person usually also has WhatsApp installed on his or her phone, right? Actually, the right term is their phone. So that creates the appearance that, the communication is done through the two apps, right? Because when you have a message to send, you look at your phone, you enter the message onto your app, you hit send, and then the other person will get immediately, or seemingly immediately at least, on that person's app, correct? Right? So it creates the appearance that, apps talking to app, right? Your message goes to their message. Okay. So, but in reality, that's not true. In reality, there's actually another piece that people don't talk about, unless you're in the field, in this computer science field. Okay. The other piece is the server. Okay. How do you know? You know because you can test this easily. Okay. How to test it? You can have your friend turn off the phone. Okay, now you know that phone's not working, right? The app, as a result, the WhatsApp is not working either on your friend's phone, because the whole phone is turned off, right? Then you can send out the message, right? And then you can turn off your phone. Okay, that means you kill your own app on your phone for the moment, right? You turn the phone off, and then ask your friend to turn on their phone, and the person will get the message. Okay, so that tells you something. That tells you that the data, the message, is not really directly from your phone to their phone. They must be living somewhere after you send it, before your friend turn on the computer, turn on the phone, right? So, and that's the server doing the trick. Okay, so in reality, what happens is, when you have a message to send, Okay, what your phone's doing is send a message to the server, which is totally transparent, but it's there. Okay, server will store the message. Okay, and will usually try to push the message to your friend's phone. And if your friend's phone is not responding, say turn it off, then the server will store the message for the time being until your friend turn the phone back on. Okay, so that is a typical application, right? So it's going through a server. Okay, it's going through a server, but it's so transparent, it's hard to even imagine there's such a thing there. Okay, you understand? Okay, so, but some apps do not need that server. Okay, for example, if you put the program we wrote for the login, remember we last class on Wednesday, right? When we were talking database, we wrote the login application, right? So, but in that case, what we did was we left that SQLite database on this project, right? It's in the project itself on your own computer. Okay, so in that case, if the data is stored locally, right? So if you turn the phone back on, and you can actually retrieve the message if the message is saved on the local database, right? So in this case, there's really no other computer, no other server out there helping your application. Okay, so that case is not a client server environment. Instead, it's just a desktop application, like I talked about earlier. Okay, now when the same thing with any other applications, when you download an app on your phone, some are built for this kind of client server environment, some are not. Some are built like our application that is database sitting on your program itself. Okay, now how do you know, right? How do you know? The easiest way to find out is once you download the application to your phone, right? And then you turn your phone into what they call on the airplane mode, I guess it's called, right? Airplane mode. That means you cut the internet connection. Okay, and then see if your app still works. Right? If your app still works, that means there's not a client server. Okay, it's a self-contained application, and then there's no server needed to make that application work. Okay, but if your app doesn't work when you turn it into airplane mode, then that means it is a client server. Right? For example, if you try to you turn on your like a map application, right? So you install your map application, and then you turn the app into the whole phone into airplane mode. The map application should not work. Okay, if it doesn't work, then that means there's no server that there to provide the data to your app. Okay, that's how you tell. That's how you tell. Okay, so here are the common. Let me actually show you my screen. Okay. All right, you see my screen, right? So you see there's a server up there on the top. That's a server, okay? And then there are a bunch of apps down below, okay? So the apps contact the server either to retrieve information or send information to store information, okay? So that is the typical client-server environment, okay, which we haven't developed yet. Okay, just so you know, usually for 248 we actually do such a application, but this semester because we spent so much time on data structures, so we didn't do it. So I just want to talk about it now. Okay, so what we wrote typically are the apps component. Okay, because we never contact the server, never retrieved anything from the server. Okay, typical 248, we're also going to write a server application. Okay, so the two applications can communicate. And in addition, the server application, because it's there to provide a service to multiple applications. So usually the server application is meant for many users to use at the same time. Okay, so so that's what a server client environment looks like. Okay, now on the server side, usually there is a database. Okay, now the database could be part of the server, Okay, in other words, they can be just another program running on the server computer. Okay, or the database could be on an entirely different computer somewhere else on the internet. Okay, so that's all possible. So, for example, you could use the Amazon Web Service, right? So, if you use Amazon Web Service, then their database is on their computer somewhere else. Okay, someone else come in. So, if you use Google Cloud, also on another computer or a bunch of other computers somewhere else, and then the server application, which is use the service database or somewhere else to either store data or retrieve data. Okay, so databases, we talked about many kinds. There are things you probably ever heard. I mentioned that MongoDB. Okay, so that is a very common. That's NoSQL. That's a NoSQL database. Okay, but there are many such NoSQL database out there. And then we have most of the SQL database, also known as relational database. Okay, relational database because all the tables are somewhat related. Remember we talked about the primary key and the foreign key. So tables could be related. So that's what we call SQL database or called a relational database. So the hat serves this piece, the database piece, right? Then in addition, we also write our own server, the server software. Okay, server software is there to serve all the apps by doing two things. Okay, one thing server does is to store data. So say app 1 has a message to send to app 2, and the message somehow has to be stored on the server, because the person who has app 2 maybe turned off the phone, so you need to store the data. Okay, so that's very common. Server will store the data. Now, whether store data on a database, like in this case I have on my screen, or the data could be saved on local data structures. Okay, the like a tree map and hash map and tree set and hash set, whatever. Okay, so they could be local without using a database. It's still possible, right? So they could be there. So, but anyway, server does two things. One is store data. The second thing it does is to facilitate communication. Facilitate communication between clients. Okay, so when one client needs to send information to a second client, to another client, then server will facilitate the communication between the two. Okay, so that's what the server will do. And then they can do it nicely, efficiently, and it can serve multiple users, multiple applications at the same time. All right, good. So far so good. So we talked about the database, we talked about the servers, we talked about clients. Okay, we talked about the roles of the servers, store data, and facilitate communications, right? And now, how data is actually sent back and forth between applications and the server, or between the client and the server, is actually very tricky. Okay, how data could send from apps to the server or retrieve data from the server to the app, right, to the clients, is actually very tricky. Why so tricky? That's because when you have a server, typically all the clients are very different. Okay, some may be using a mobile phone, some maybe use a Android phone, some may use an Apple phone or whatever. Some may use in tablet, right? Some use a computer, some may use a laptop of all different operating systems. Okay, iOS, OS, or Windows or Android, and you name it, Linux. So the app speaks all different languages, but they all need to contact the server, right, to either retrieve data or send data. Okay, so that turns out pretty tricky to do that, right? So a person whose name is Roy, you need to remember this name, Fielding. Okay, he in 1980s, I think, he wrote a dissertation, a PhD dissertation or thesis, and he and a bunch of other people proposed something called HTTP and REST service to do this work. Okay, so those are two things that turns out to be very, very important. They are actually one of the very few most important achievement in computer science. Okay, HTTP and the REST service. Okay, HTTP we all use, right? It is a protocol we all use every day, right? So you often would type something like, let me see, get some, give you a HTTP command. So this way you will know what I'm talking about. Then we're going to dissect the HTTP. So that's what this is called a URL, right? URL, you need to remember, this is called a uniform resource locator. Okay, very important. So whenever we need the communication between two computers now is a commonplace, we just say HTTP : right, // So that's the HTTP. Okay, that is what we call protocol. That's called a protocol. Okay, Protocol basically defines the rules, okay, of a communication between two computers. Okay, so that is revolutionary, okay, because that's the first time the idea of having two computers communicate, not only just two computers, all computers in the world to communicate, okay, made that possible. So that protocol, HTTP, made all communications among computers in all the world become possible. Make that be possible. So it's HTTP, okay? Then // then you have the domain name. So I give a domain, it's like a www.google.com. So that is domain name, or called domain is the name of the domain, whatever. So that is the unique address of a computer, of the server, or of the computer, or called the server. Okay, so a domain name is a unique name for a computer or the server on the internet in the world. Okay, so that made it possible for any computer in the world to communicate with another computer in the world by coming up with such a domain name. Okay, domain name is in English, right? But we can alternatively, we could use the IP address. Okay, which basically goes like say 120.10.5.200, something like that. Okay, so IP address is an address, okay, made of four numbers separated by dots, okay, and that can uniquely identify a computer on the internet. Okay, now each number is made of 8 bits. Okay, because computers don't really use decimal numbers, you use the binary. So each number is really just 8 bits of binary numbers, okay, or binary digits. So altogether is 8 times 4. So that gives you 32 binary digits, or 32 bits. That's what we call it. Okay, so that will give us, in theory, 2 raised to 32, about 4.3 billion unique addresses. Okay, that's just pure math. So if you have 32 bits, meaning zeros or ones, a combination of both, and that can potentially give you 4.3 billion combinations. Okay, so essentially they allow you to identify 4.3 billion different computers on the internet uniquely. Okay, in reality, that's in theory. In reality, it's a little bit more complicated, because what happened is the policy was originally designed to give a company or institution a block of the IP addresses. So it's not giving, the IP address is not giving out one at a time. Like, oh, you have a computer, you get one. You have another computer, you get one. Instead, it's like Suffolk will get 2 blocks. Like Microsoft will get a huge block because it's a bigger company. And if you have another bigger company, Google, you'll get another huge block. Okay, now when a company gets such a huge block, they may not necessarily use all of the IP addresses, right? They may say, oh, our company is so big, I need, say, 1 million IP addresses, but they don't really have that many computers, at least yet, right? So they maybe only have a 500,000. So, but the whole block is already given to Google. So basically nobody else can use it. So basically 500,000 of IP addresses gets wasted, right? Because they're not using, but already taking the IP addresses, right? So as a result, we are the total number of 4.3 billion IP addresses is actually used less than half, and we're already running out of IP addresses because the bigger companies that hold on to those unused IP addresses don't want to give out, right? Then new companies having a lot of trouble of getting one. Okay, so that is the current situation, and this way of doing IP addresses is called IP version 4, IPv4. Okay, now people say this is not fair because a lot of companies still cannot get their own IP addresses. So now the international organization is proposing use IPv6. Okay, version 6. Now, IPv6 use 128 bits. Remember before 32 bits? Now this is 128. So 128 is 2 raised 128. Okay, this is the humongous number because that is meant for use in even distant future. Okay, so in the future, we're going to have not just the phones need IP address, or the cars, microwaves, refrigerators, toasters, washer dryers. They all can have their own IP address because we will have that many available to everybody. Okay, but that's not widely used yet at this moment because the bigger companies, they don't want this change because they don't have a problem. They have the IP addresses enough for them. Anyway, so let's back to our HTTP protocol. When we use, we put the English name of the domain, say www.google.com. But in reality, the computer does not really know what that means. Okay, because every computer is uniquely identified by IP address, not by the domain name. So what happened is there is another program somewhere or another computer somewhere called DNS server. Okay, DNS stands for domain name systems or domain name service. And that program will translate any English domain names, okay, to the corresponding unique IP addresses. Okay, that's called DNS service. Okay, so because of it, we could use the English name www.google.com as a domain name, or we can directly use the IP address, whatever the IP address is, like 120.10.5.200, to indicate that unique computer on the internet. Okay, so overall then is a domain is a unique computer. Okay, identifier. Okay, so that is the second thing after protocol and a domain, right? Now the third thing is after slash, you have something, say search or whatever a phrase, and another slash, forward slash, and this is called a path. I'm sorry, it's called a path. Okay, now what is the path? Path is used in the past, initially, is the directory where on this computer domain, the unique computer, okay, on this IP address, the directory where the resource is located, right? Because the domain name will only give you that unique computer on the internet. It's a Google server or whatever, Microsoft server or whatever server, right? So SUNY is a server on our campus. Okay. Now after the slash, the path will indicate further where on that computer the resource is located. So in this case, will be in the directory called search. right? Just getting to the computer is not enough because the computer can hold so much variety of information, right? But with a path, you can actually specify where that information or the resource is needed. Okay, so after domain name is the path where the resource is located on that computer. Okay, now after that, sometimes you can have a question mark. Okay, that means there's no necessary, there's no slash, it's just a question mark. Okay, then add that the folder. Okay, that's where resources is located, right? And a search folder. Okay, now this means that's the beginning of a list of parameters. Okay, so for example, I can say Q equals something, say the Facebook. Okay, so and then you can see there's an equal sign, first of all, right? And that tells you that this is a key. Q is a key, is the name of the key, and this is the value. So key value pair, and that makes up the parameter. Okay, that makes up parameter. So what is that thing then? So the parameter after the question mark, the question mark starts this parameter. It further specifies, right? Further specify what resource exactly in that search directory you need. Okay, because in the search directory, that's where the resource is located, right? But there are so many different kinds of resources. And you want to be specific. I only want the query on Facebook, even though there are other things there, but I don't care. I just want the Facebook related. So you specify that, okay, by putting a parameter. And you can have multiple parameters and then connected by at, like a at, like at sign, right? Or ampersand. And then I just have one. And then you can also have another symbol, means pound, right? And then say result. Okay, so what we call this is called fragment. Okay, now fragment usually identifies a point. Okay, sometimes we call anchor point. Anchor point. Okay, sometimes you don't need it, but sometimes you do. For example, if I get a page, okay, I want to get a particular page from regarding Facebook on the search directory on the Google server, but I want to further specify where on that page. Right, when you do HTML, you can set up an anchor. Just the page is long, but I don't want to show the beginning of the page. I want to show one part of the page and set that as an anchor. So when you go to that page, you will land at where the anchor is, not the beginning of the page. Okay, so that's a pretty common HTTP statement, okay, or resource URL, resource, uniform resource locator. Okay, we use this all the time, but we saw this on our browser address field, but we don't really pay much attention unless you are a computer science student, right? You see this all the time. You see the question mark. You see sometimes with a equal sign. Sometimes you see the pound. You don't really pay much attention. But from now on, when you go to here is my here is my I can show you. I'm just copying this from my Meet page, right? Remember, you can look at yours as well. It's the Meet page, the Google Meet, right? This is what I have. See if I can paste over here. There you go. But it's small. I'm gonna blow it up. There you go. You see, HTTPS, okay, is a encrypted version of HTTP, but so it's just like a variant of HTTP. Now it's common, but originally when the whole thing was designed, okay, there was no HTTPS. S stands for secure, right? So we just had HTTP. So now people use HTTPS more common because the data sending back and forth between client and server is encrypted, okay, for security reasons. So now we use HTTPS, but the idea is the same, except the data back and forth is encrypted. HTTP is not encrypted. Okay, so we still call this HTTP protocol. And here is the computer we call domain name, right? And we can uniquely identify this computer or a group of computers that belong to Google. Okay, how do you know belong to Google? It says google.com. Okay, so this computer name usually just meet. Okay, or it's just a name that can be redirected to other computers. So anyway, so this is the identifier of the server, which is unique. Now, we could use the IP address if we know what it is. Okay, in that case, then we will not put in meet.google.com. We will say 10, 20, or 12.20.15.100, something like that. In that case, then we do not need to use the DNS service. Okay, because we did not need the translation from the English domain name into an IP address. Okay, but because DNS does such a good job, so the delay is like a fraction of a second, so we don't really care. Okay, here is the path, okay, where this resource is located. Okay, the path. Remember, after the domain name is the path, right? And then you see question mark. That's the beginning of the parameter. And then the parameter is a key value pair. You see, one key value pair, another key value pair, right? And connected by ampersand. Okay, so there are two parameters. That means two pairs. Okay, one is the authenticated user equals to one. I have one. I don't know if you have one or no. For yours, you don't have one. What do you have in here? What?
It's the one for me.
Is the one for you?
Hmm.
Okay. So authenticated user, because I'm the host, I guess only they know what it actually means. Okay. So they have their own scheme. So maybe because I'm the host, so that's one, I started it. So that means the host started it. And PLI, I don't know what that means. Only they know what it means, equals to one as well. So that's the parameter. Okay, this is hard to decipher, but later on we're going to see some easy ones to decipher, and then we can get the data that way. Okay, so that is a typical URL, uniform resource locator. Okay, so this turns out to be revolutionary. This is one of the biggest thing in computer science ever. Okay, because now because of this, all computers in the world can talk to all computers in the world. Imagine that, right? That's a huge thing because, right, they all start to speak the same language, even though every computer is different. Okay, and all the different data are different, right? So this is huge. This called a protocol is huge. That's revolutionary. HTTP protocol is huge. So you need to remember that. Okay, now go back to my original. I'm sorry, my original. So go back to my original diagram. Let me shrink this. Okay. So now we have the protocol, right? That means now it's possible for computers to talk to each other. It's possible to connect to each other, right? You got it? They can locate each other. They can find out where the resource is and exactly what part of the resource it wants. Okay, so HTTP allows communication, makes the communication possible. Okay, now there are still questions. Once you communicated with another computer, say two computers now are in contact, right? By doing this, by HTTP. Now the next question is, what language should they speak? Okay, how data should be transferred from one to another, right? That's huge, right? Because just like humans, we all can talk, and then we still have to decide on what language we're going to speak. Are we going to speak English? Are we going to speak French, or speak another like Spanish? Whatever language you have to decide on, right? So because the language is made of two things for the most part, if you think about it, right? If you want to communicate, the two things needs to be known. One is nouns, right? Because nouns are indicating things, right? When you need to communicate, you have to agree upon certain nouns. Say we have a table, this is the cup, this is the mug, this is the pen. We all have to understand what they mean. So there's a nouns, correct? So that's something we have to be able to uniformly understand. And just have nouns is not enough. Okay. We also have to know what we're going to do with those nouns. And then those are called verbs. So those are two things that we understand that are critical for communication. Okay, either human communication or computer communication, right? You understand? Okay, nouns are okay. We could, they again made at that point was like a revolutionary idea that we could keep on using those certain format to indicate what is what. Okay, we're gonna see that. And then verbs is a little bit more complicated if you think about it, right? For example, verbs are usually dealing with the nouns. Then, for example, you can have say I have my coffee, then the verb will be drink, right? Coffee is a noun, and then the verb will be drink coffee, correct? Or make coffee. And then if you have a car, then you would say drive a car this time. You don't say drive coffee, you don't say drive or drink car. You understand? So the verb is a little bit complicated. Nouns the more straightforward. What is it is what it is, right? But a verb is complicated because you don't want to have too many verbs, right? You don't want to have every noun has its own verb, then you lose the meaning, right? Because the whole thing becomes too messy. Okay, so but eventually this guy Roy Fielding and a couple other people, they thought about it to say, hey, there are some verbs that are kind of universal. Okay, and if we stick to those verbs, then we can accomplish most of the work. Okay, so these are the things called a get. Okay, so it doesn't matter you're dealing with a coffee or car, right? You can always get a coffee, get a car, right? And another verb is post. Okay, post is hard to understand, but you will soon understand. Okay, and then you have a put. Okay, then you have something called delete. Delete. Well, delete. Okay, and then you have something. Yeah, so there's a couple other things like an option, then you have a header. So those are not used that often. Option. Oops. How can I move this up a little bit maybe? Yeah. Then you have a header. So there's a few others. So, but mostly the verbs we need turns out just to be get, post, put, and delete. Okay, now let me explain to you what they actually mean. Okay, get, it means that I need to get information, get the resource. That's easy, right? So whenever I'm a browser, you try to retrieve a web page or retrieve some information from a server, then you use a verb get. That means I want to retrieve. I want to get something. That's easy, right? Doesn't matter what it is. Maybe the picture, an image, maybe a song, maybe a paragraph, maybe a document, right? So get will work. It applies to all these different cases, right? So get means just to retrieve. So that's very good. Good? Understand that, right? So that's used almost exclusively on web browsers, because web browsers basically allow you to retrieve information, right? When you go to Google, you search something, you basically just retrieve information. So that is get. Okay. Now, then there is a put and a post. Okay. Now, strictly speaking, post is to there's some differences. Let me see if I can find the, yeah, I want to tell you the right thing, because sometimes they use the interchangeably, put and post, but there is difference. There's actually very important differences. Let me see. I'll make sure it's right. Okay, because one has to do with the update. Okay. Okay. The rest. Okay, okay. Post means that you. Let me see if I can make an example here. How can I create an example? So basically, let me just do it this way. Post and put are sending information to the server. Okay, basically sending information to the server. Okay, so get is to retrieve information. Post is to send information. Okay, send information. Now, one is more secure. Okay, I think I wrote it down here. I just here post, that's the difference here. Okay, yeah, so post is to send data to a server to create or update a resource. That's a post. That's another verb. That's the second verb. Post is used to send data to a server to create or update a resource. The data sent to the server with the post is stored in the request body of the HTTP request. So, in other words, the data sent is stored in the body of the request. So, what that means is when your browser needs to send the data, or your computer, the client, needs to send data to the server, right? If you use a post, what happens is your computer, your client, will wrap the data into a request, into a message. That's the right way, request message. Okay, so the data actually is embedded in the message itself. Okay, which can be encrypted. because you're sending a message, and so that could be encrypted. Okay, so for example, you have a message, it will start like this. It's a post method, and then you will tell this is the body, and the body has the name 1 equals the value 1, and name 2 equals the value 2. So that is the body of the message. Okay, so the client will send a message to the server if you use a post. So because of it, the data can be encrypted. So this is safer method than put. Okay, so post is one of the most common HTTP methods. Some other nodes on post requests are never cache. So that means if whoever gets the data, you should never cache it. So that's another security measure. In other words, you do not want to store your data temporarily in your memory, and that's what they call cache it. Okay, you should store the data right away. Don't cache it. Okay, and also post requests do not remain in the browser history. So if you use the browser, the data will not be stored in the browser history. Okay, because that's another security measure. Otherwise, somebody could potentially say, get your computer, get your client computer, and go to the browser history, and we'll find out what you sent, right? But that's because it's the post. Then that's not in the browser history. And also, post requests cannot be bookmarked. Post requests have no restriction on data length. So you can send as much as you want. So that's post. Again, post is to send data to the server, okay, in a secure way, and there's no limit how much you can be sent. Okay, so that's called more or less like a preferred way of doing it. Okay, especially you have something confidential, something huge amount. Okay, now the other word, the put method, is also used to send the data to the server to upgrade the resource. However, the difference is put requests are idempotent. Idempotent has its meaning. Let me explain. It's a very strange word. What it means is, if you put the same data every time, it's not going to change the server. So if you did once, say you add John Doe to the server, right? You send John Doe to the server. If you send 100 times, the server still only recognize the first one. The other ones, it won't make any change. It will not make any difference. So idempotent means the server will not be different. The value, the server will not be different if you do this request multiple times. It gives the same result. Remain the same. The server remain the same. That is, calling the same put request multiple times, we always produce the same result. In contrast, the calling post request repeatedly have side effects of creating the same resource multiple times. So when you do post John Doe 10 times, then you're sending, the server will receive John Doe 10 times, will save John Doe 10 times. But when you put John Doe 10 times, the server will only receive John Doe once. Okay, so that's another difference. But plus, there's other things like it's not a body, so it's not going to be the data is actually not embedded in the body of the message. There's no message. Instead, the data is sent in the URL request. So sometimes when you do things, I'll give you an example. Let me open another browser here. I'm going to say Google. So this is a Google. So if it's the Google price, okay. So down $12. So here you see that's the resource. Let me see if you can copy this. I'm going to copy the URL, okay, and then put it into here so you can see better. Okay, so put it over here, maybe. Okay, so now, okay, now you see this, right? You see, I send out the GOOGL. That's Google's symbol. Okay, stock symbol, right? Now this is a typical put, not a post. I'm sending that the request to get Google stock price, right? See, the request is actually embedded in the URL. You see this? That's the original URL, google.com. Then I have GQ equals the query equals Google L. So I'm searching for Google L. See that? So that request is actually embedded in the URL. So this is what is sent to the server, not a separate message. You can understand this like not a separate email package. It's just a URL. So you can see what you send is obvious. You send out the Google symbol, right? And it's from your Chrome. Then you have some other things, user's ID, and also how the text is encrypted, not encrypted, encoded using UTF-8. Using this way to encode because we're using Unicode, right? Unicode because we can potentially search other languages in google.com at google.com, right? So it's using Unicode. So the encoding method is UTF-8. So this is the way. So this whole information sent up to the server is encoded, embedded in here, not in another message, in other words. Okay, so that's just the put. But if you do the post, then this will not change. You still have www.google.com. You don't have anything behind it. But the request is embedded into a message and sent behind the scene. And that can be encrypted. And this is not encrypted. So that's why that's the difference between the two. And then we have head delete means to delete the specified resources. That's another one used often. Then for options, describe the communication options of the targeted resource. In other words, what options you can have to the resource. Okay, so and that's not used often. And then also we have something called a head, not a header. Head just is like a get, but only retrieves the header of the message of the HTML file. So in other words, when you try to get to the resource, right, it comes back often as a HTML page if you use an HTML protocol, okay, the language. So the if you use a head method, then it's like a get. However, it doesn't give you the body of the document, of the HTML document. Instead, only give you the header of the HTML document. Okay, if you just want to see if the data is there or not, if the server is there or not, the resources there or not, then you can use the head instead of getting everything. Just to make sure you can get it. Okay, the resource is there. Okay, so you won't get the body. So sometimes you use that to test, see if the resource is available. Okay, so these are the commonly used methods. And then if we go back to the server, okay, so that is how a client or clients in general communicate with the server through using these methods. Okay, and these methods are presumably universal head, not header. Okay, so universal they apply to all kinds of nouns. Okay, now what are the nouns then, right? Nouns are specified by typically two protocols. Two protocols, very common protocols. One is called the JSON protocol, JSON. Okay, stands for JavaScript object notation. Okay, another one is XML, extensible markup language. So these are the two commonly used format, okay, that are used to encode your data. that can be applied by those few verbs I mentioned earlier. Okay, so the nouns are embedded in the JSON or XML document. Okay, now among the two, JSON is more popular, more common than XML. Okay, then we're going to see the differences. They're actually very interesting. Okay, there are some other format we don't we are familiar with, but it's not used often. One is, for example, FXML, right? We know what that is because when we did our scene builder, remember FXML? That's what we use. That's the format we use to code our controls, our interfaces, right? The containers, the controls, FXML. But that's not used for this universal data communication. Okay, the one used the most often is JSON and XML. Okay, not FXML. Okay, now there is another one you heard all the time, which is HTML. Okay, hypertext markup language, which is used widely, right? Or every day by billions of people. Okay, now this is meant for web browsers. Okay, so they are meant for web browsers. Now, what's the difference? What's the difference between the two? Turns out these two are huge difference. Okay, we already were very familiar with HTML, right? That's associated with the browser, correct? Okay, now this is meant, as a difference, meant for humans. Let me clean up this. So that's meant for humans, right? Why is it meant for humans? Because if you look at HTML code, let me see if I can search some HTML code for you. HTML. Find some HTML code. Okay. So I just randomly get some HTML code example. Then I will see if I get a better one. Yeah, I have one, but it's not very good. Try to get a nice one. There's so many, but it's hard to find right now. HTML code. Crazy. Here. Okay. Okay. So here is, there you go. I'm going to put it over here. All right, so that's the simplest HTML code, right? So you can see this is HTML5. How do you know that? Because you see the tag called exclamation mark dot type. That's HTML. So whenever you see this, you know that's HTML5, which is the latest one. And then you see there's a HTML tag and there's a closing tag. No big deal. Okay. Then this is the body. Then in between, this is the body of the HTML document. And then now what you see here is H1. Okay, that's the heading, right? That's level 1 heading. And then the ends over here. So this will be a bigger lettering. And then you have a P. P means a paragraph. So that's the regular font size. That's the first paragraph, right? So we can try it. You can see it will look like something, hopefully, like this. You see, this is the H1 heading, big, and the P small, that's a paragraph. Okay, so you can actually, can I? Yeah, I can edit it here directly. So now I have another paragraph. then you can say my second paragraph, and you run it. You see, my second paragraph is rendered like this. Okay, now what that tells you? What tells you is it has a format. It has a tag, opening tag, and a corresponding closing tag. So it's here and here, right? But most important thing is you don't really just have data. You also have the format, the size, the font. You can have all this. We didn't specify it, but you could have font and the size. You could have color. You could have style. You could have alignment. All those could be rendered on a browser properly, right? So what do we see here? You see, how easy, right? I could basically right-click anywhere here and get the inspect, and I can see the HTML document. There you go. See, that's the HTML document. You see this? It always has tags and it tells you the style, the positioning, the location top, right? And what the style is here is the outline and all the style. And then you will see other things like a form. You see that's a form, tells you there's a form there, and all 9 yards. No frame. This is iframe. Okay, anyway. So that is HTML, right? But that's only for the browsers. That's why we say this is really for humans, because humans care about the appearance, right? The font size, alignment, and then the location, positioning. Those are meant for humans. So those are called HTML. That's for humans used widely today, right? But JSON, HTML, XML, okay, these are, I'm gonna write it down here. Okay, let me say, I'm gonna write down here. They're not meant for humans. Instead, they're meant for what?
Cats.
For what?
Cats.
For cats.
Computers.
Okay. Yes, they're meant for machines. So that's the difference. Okay, they're meant for machines. So if you look at these kind of format, JSON, XML, there's nothing like the size, the color, the positioning. It's just a pure data. No embellishment. It doesn't care how it looks like. It's meant for computer. That's a huge difference. So I said last week that there is a parallel universe. That's the parallel universe. There's a whole internet outside of our experience. If you're just a regular user, not a computer scientist or not a web developer, there's a whole universe out there, right? Computers are talking to each other without a human involvement. It's all data coming back and forth, It's all between computers, between clients and the servers. Totally transparent, even busier than the kind of HTML we are doing every day. There's a whole infrastructure out there that's passing data between computers. They're talking nonstop. I mean 24/7, nonstop. Beyond what we are experiencing the HTML, the browser. The pure data back and forth. You see that? That's how interesting this is. But we don't realize it. Okay, now what is a server then? Server is a computer meant to communicate with client computers, not to humans. So server don't talk to humans. server don't talk to humans. They don't speak HTML. Instead, it speaks its own language, which is composed of nouns coming with JSON in JSON format, or to less extent, XML format, using those few verbs, universal verbs like a get, post, put, delete, option, and head. Those are common ones. There's a couple, very few other verbs, but not used commonly, but very, very few. Okay, isn't that wonderful? It's interesting. Don't you think it's interesting? There's a whole world, there's a whole universe out there. Data sending back and forth, nonstop. Speaker language, most people don't even know. Okay, so let me see. Let me move this away. Okay, so that kind of a way of communication is called a RESTful application or RESTful service or REST service, however you want to call it. And REST means I don't even remember this. Representation. Let me see. Representation of representational state transfer. All right, let me write it down. Representational state transfer. Okay, it's an awkward name, and that's a REST, REST. That's where it comes from, REST. And that's the original contribution by this guy, Roy Fielding. Okay, now combining HTTP, this is a part of HTTP, don't forget that, right? The verbs and now, this whole thing is HTTP. Okay, that's the protocol, or HTTPS nowadays. Okay, and that requires nouns and verbs. Okay, verbs are the few I mentioned. Nouns are in this kind of format, JSON or XML. And because of that, now all computers in the whole world can talk to each other and can send information back and forth to each other. Okay, and that's what's going on today. Okay, so when you drive around, turn on your GPS, right? You have, just put this into a concrete example. When you drive around using GPS, your GPS program on your phone, okay, is an app. So you are this app, okay? And then as you drive, if you send you are getting data from the server. Okay, if you use Google Map, then Google server will send you all these road information and the restaurants, gas stations into your app, into your phone. Okay, nonstop. As you move your like a GPS location, okay, and then the server will send your corresponding data to your app. Okay, so essentially you're using get. And then what are the nouns? The nouns are restaurants, okay, which is what? It's array. Restaurant is array. The array contains all the restaurants in a certain radius. Okay, and gas stations, and then exits if you drive on the highway or other roads nearby, and whatever information. Those are all really nouns. restaurants, exits, and highways, right? Rest stops, so on and so forth. So they're all coming in the form either JSON or XML. And you are using get to get them. Now, as you drive, if you say, I want to look for a, say, Italian restaurant, okay, you make a selection, say Italian restaurant, then you are sending a put because you are making a request and you don't need a security. So Italian restaurant, that term will be sent to the Google server. Google server will retrieve all the Italian restaurants and in a certain radius, say 5 miles, and then will package another JSON document, okay, which is made of key value pairs and sent to your app, and your app just display it or add it superimpose on the existing map. So that's how it works. Okay. So now, any questions? I've been talking a lot. So any questions so far? Any questions? No? No questions? Okay. If there are no questions, then I'm going to show you what are the differences between the two format, right? JSON and XML. So let me see if I will just go find a JSON example. And let me see if I can find yeah, this is a JSON example. I think I have one. Remember. Do I? Well, this is a JSON example, but no. That's a JSON, but it's too short. I want a more. So this is the example. It's a better example, I guess. Now you see, this is a JSON example. You see, it's made of, first of all, curly braces, okay, indicating that's a JSON document. So this will be sent from either from the server to the client or client to the server. Okay, that's actually made of nouns. You see, name is the key. Okay, the key is in double quotes, and a column separating the key and the value. Okay, so name is John, age is the key, the value is 30. So, so because both keys are definitely has to be double quoted, period, no matter what, because it's treated as a string. Okay, and then the value, if it's a string, is also double quoted, but if it's an integer or number, then you do not. Okay, so so age is 30. That's just a integer. And then look at this. Cars, that's the key, right? Just as usual, is a key. Then followed by column. Now you see this is an array. You see? Right? Square bracket. So inside this array, there are 3 elements. Ford, BMW, and the Fiat. So those are 3 names of 3 brands or makes of the cars. So that's a very simple example that that of a JSON object. Okay, so that tells you JSON object can contain simple data. Okay, just the key value pair, can also contain arrays. Okay, now it's also, you realize that's the way how smart this is. It's all text-based. It's text-based, unless you encrypt it. Encrypted is a different story, right? You can scramble it any way you want using whatever algorithm. But originally, it's all text-based. Why is text-based? Because that made it possible for any computer running any operating system to understand it. Because no matter what operating system, what computer, they all understand the text. So that made this whole thing universally acceptable or understandable. Okay, so it's all text. And also you know what each piece of data is, because there's a key in front of it telling you how to understand John, how to understand the 30, how to understand this, because it has a label in front of it, which we call key. Okay, so just something like this is enough. You can see it's just like self-explanatory, right? You send it to any computer will know the first one is the label or the key, then followed by the value. So if you tell every computer in the world that's how you should understand it, then everybody can understand it. Plus, the language is coded in text. And text use the Unicode or use the ASCII code, and that's universal. So because of that, the whole thing becomes universally understandable and can be used by any computers, any programs, any operating systems in the world. So that made it possible. Isn't that cool? It's not that hard to come up with, but this person came up with first time is a genius, right? So that is that is the document or the object that send between the server and the client is in that format. Okay, now that is just a vehicle holding the data. Okay, now your application, if you're a Java application, you don't use that kind of format, right? If you use Java, you don't use JSON object. You use your Java object, correct? Yes? For all those 2 years, we've been writing Java objects, right? We never use JSON object. JSON object is not needed in Java, right? But if you use another language, they may not even have object. They may not even object-oriented. They don't even know the concept of object, correct? So every language has a different way of talking among themselves. But in order to communicate with the server, what each application has to do is whatever language you speak, if you have data to send to the server, then you better do this thing, which is convert your object or whatever you like, your native, even either Java object or just pure strings, and reformat it into JSON object format, which is the one I showed you, then send it. Because that will only, by doing that, it will guarantee whatever you send can be accepted by the other party, right? If you just send your Java object and the other computer server may not speak Java, right? You will not understand your Java object. But of course, if you know that a computer speaks Java, then okay, but we don't want that kind of special treatment. We want all the computer in the world can understand each other. That's why we have to refrain from speak our native language. So we don't want to speak Java. So what we do is we agree upon a common language, which is JSON. So any Java data or other kind of data you want to send to another computer, what do you have to do first? You have to convert your data into JSON format. Basically, just format it, right? Writing like print line, print, and using printf. What we've been doing, right? We know how to produce a JSON format. It's very simple. It's a text format, right? So that's what we have to do. And then when we send the JSON object over to the server may be written in any languages. Okay, these are the common languages we use to write a server. Okay, let me see if I can get rid of this. Okay, here are the languages we use to write it. So we could potentially use Java. I'll make it bigger. Okay, so that's a common language to, to write this Java software. Okay, specifically, we have something meant to use develop Java server application, something called a Spring Boot. Okay, It's very common used to develop Java server applications. Okay, Java is one, and then JavaScript is another one, and specifically the product for using to do the server is called Node.js. Okay, so you probably ever heard of that. And then there's another one called Ruby on Rails. Probably ever heard that. Then ASP.NET, that's Microsoft. That's another one. And then you have another one. You have many others, obviously. But this most common one, I don't even remember what's called. Used to be the number one. My God, what's the language that they use all the time? Forgot it. Okay, if it will come back to me, I will let you know. Okay, so these are the languages people use to build the server application. Okay, I wonder if I can find that language. I think I can find from here.
Is it like PHP or something?
PHP, that's the one. That's the one. PHP. Okay, that used to be the number one most popular language used to do the server. Now we lost the appeal and nobody uses it anymore unless it's like a legacy application. There are many reasons, and
that's what Facebook was built on.
In the beginning, everything is because that everybody, the first protocol, like a prototype, is done on PHP, but cannot be scaled, and the code is messy, and not really object-oriented friendly. There are many reasons. So today, very few people will learn PHP because it's like a language has no future. But still tons of web servers using PHP just because of a history. Okay, so anyway, so these are the common ones. So but again, say whatever apps you use, if you have data to send to the server, you just have to format it into JSON format. And then the server, whatever language you use to write the server, has to take the JSON server and decompose it back into the native data format. Say if it's Java object, right? So if you all use Java on both ends, then on the client side, the Java object has to be turned into JSON object. Then the server Java on the server side have to turn the JSON object back into JSON Java object. Okay, so it's a pain in the neck, but because today the world is complicated, we have so many different languages, so many different operating systems. So that's the sacrifice we have to make. So everybody does it. Okay, so almost universally in the whole world now, we just use JSON, and then to a less extent, people use XML for many other reasons. Okay, now I'm going to show you, I have 2 minutes. I'm going to show you what XML code looks like, okay? And which is interesting because it's different than JSON. Maybe something like this. Okay, so this is more like a fXML. You see the name is similar. So let me see if I can. Okay, that's not a great example, but but I will show you here. See, that's the XML. You have a header, and then you see the tag bank account. It's just the XML and HTML. You see, is an open tag, closing tag, the number is open, and then the closing is number, and the type, and the closing, then this is the value. So instead of a key value pair, now you have tags, and the values are enclosed into the open and closing tags. Okay, so probably we remind you the fxml tags we had when we do sim builder, or probably reminds you the HTML code we saw earlier or you saw before. Okay, so that is the XML, extensible markup language. That's what it means. Now, this serves the similar purpose as a JSON because you always know what the data is or the value is about. For example, this is a type checking account. This is the number, bank account number. This is the open date. This is the balance. This is the account holder, last name, first name, so on and so forth. You got it? So it's like the JSON, but is a little bit tedious because it requires the open and closing, right? It is tedious. But it's better than the HTML in the sense that you can create as many tags as you like. You can create a custom tags. Okay, so these tags can be created however you want. It's not like an HTML. You only have a certain tags you are limited to use. You cannot create your own tags, right? So this you could. So this is XML like fxml we did before, and in fact that's how Android apps. Okay, what Android app use to code is GUI, right? fxml is for GUI, right? So Android GUI is coded by is marked or coded by XML. Okay, so you can see it's still user friendly. It tells you what it is about. It's very clear. It's just tedious. It's very wordy. Okay, very wordy. You see, there's a lot of words and very compact compared to the JSON example, which is very straightforward. Like it just tells you this is employee made of this many fields. It's like an object, right? So this is the class object has all these fields. The fields could be different like a instance variable and a value, right? And it could be an array. We showed you array before. So so this is more, I guess, a more complicated example. You can see this one. That's like an order information. Order number is this, date is this, tracking info number is this, customer ID is this, customer information is an array. You see? Is an array, and in the array you have this many fields: customer ID, first name, last name, address, city, state, zip. So that's an array. So it can be easily turned into a Java object. A Java object can be turned into a JSON object fairly easily. So that's why it's called it's used more often. Okay, because it's more object oriented than XML. Make sense? Okay, so we are going to actually apply this into our Java code next time. Okay, we'll turn our Java object into a JSON object by using one of many classes come with Java to do that. Many tools come with Java APIs that will turn any Java object into JSON, and we can also take any JSON object, turn back into a Java object next time. Okay, and there are similar tools for every language because now it's essential, right? Because JSON is the standard across the universe. So we need to be able to do that. And then I will show you an example how to get the data from a government website or some government websites and how data will look like and how they come down, how to do queries. So that will be really like eye-opening. We used to do such an application for college application, like an application for helping high school students apply for colleges, because I think about 6,000 schools, colleges in the U.S. They report their college information to the government. So they're going to put into REST service. So everybody in the world can get the data in any way they want, and they can sort the data, retrieve data in any form they want. So we can show you an example how that's done. Is quite amazing. Okay, what can be done. So that will open the door for your future experience if you want to develop things used broadly. Like people use like a weather apps. They all get the data from one location using REST service, like JSON data from NOAA. Okay, so get the every day's temperature, precipitation, humidity, whatever, right? Get from NOAA. And then you just get the data and then build your GUI to display it one way or another. That's why when you go to Google App Store or Apple Store, you will see all kinds of weather apps, right? They just the look is different because the app is different, the GUI is different, but the data is from the same place, from NOAA, okay, by using JSON, using REST service, and the NOAA provides that service to everybody in the world. So that's how things work. And a little bit late today, and then I will see you on Wednesday, unless you have any questions. Then Wednesday will be the last lecture. Hopefully we can finish in about an hour or half an hour. Then we could mention a little bit, show you a few simple examples of multi-threading, which is also very interesting, how to write a program that can do multiple things at the same time. Because so far, our program is just doing one thing. Remember when we do the main method, right? Whatever sequence of statements we put in is always executed in sequence, right? The first one first, the second one, the third one, the fourth one, until you finish the whole main method, until you finish the whole program. But we're going to write multi-threading programs that will do multiple things at the same time. Okay, so that's it. If you have any questions, you can ask it now, or you could send me through an email. All right? Any question you want to ask it now, or it's kind of late, I know. Otherwise, I see you on Wednesday. You have a great week. Okay, adios.